All right, so questions from review 3 that you have that you could not answer within your groups. All of a sudden we have none. Lottie? 9. So I'm not going to do number 9 because that's part of just kind of being able to read the question. Let's start with what the question is asking you for. It's asking you for the nth derivative. I would not try and find it. It's a pattern, so write down the first derivative, then try the second derivative, then try the third derivative. You should see a pattern show up. Okay, so try that first, and if you still can't get it, then I will go over it. Those are the type of questions you don't skip. You try and figure out something. All else fails. What did it ask you to do? Take a derivative. Okay? All else fails, try a derivative, especially for response. That exclamation point in number 9, that's a factorial. So this means n. Oh, actually, let me do it with a number. It looks a lot easier. So the name of that is called a factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. Okay? So that means factorial. Others. Julie? 24. Yes. That one is kind of tricky because they're asking you for h of x. And then all I could figure out just by the question is h of x would have been the same as g primed of x divided by f, or e to the f of x, right? If I look at the way I just did that question. I looked at what it's asking. I took the given information and tried to make sense of it. This, I'm stuck. Did you notice all the answer choices don't have g in it, right? So this is probably okay, but this numerator is not okay, so what do you think I'm going to find? Find g double prime. They gave you g of x, so find g double prime. I'm going to find g prime just to make sure you don't do it incorrectly. Chain rule, that's your inside. E to the, that's the derivative of the out. Leave the inside exactly the same as it was. Multiply by the derivative of the inside. But now that I did that, when I go to do this guy, not only do I have a chain rule, and I also have a product rule. So now I have 2 rules to do. Once I find that, I'll be able to substitute it in for g double prime, and it will simplify. You will get an answer. But listen to the way I did the question. I read it. It looked confusing. I started with what they asked me for. I always start with the question that they ask me for. I write it down and try to use anything they gave me to make a definition. Okay? That's how I'm doing pretty much every problem. All right, others. Anything else before I start review? Those were the ones you guys had written? You had a list, your group had a list to ask. Yeah, it was those? Okay. Michael has a question. Yay! What's Michael's question? Your teammates are telling you that you have a question. Number 3. I'm actually surprised no one asked that. No one else had that question? Usually I can just tell by how messy it looks. So question was h prime of x, and my h prime is allowed to have g's and f's, but no prime symbol. So h prime of x, I'm going to just give a little hint here that this would be f of x, whole thing, squared minus g of x, whole thing squared. So when I take the derivative of this term, what rule do I have to use? Chain. So I'm just going to leave it there and start with that. If you start with that, you're going to still have primes, but your answers, none of them have primes. So then you use what f prime is the same as negative g, and then g prime is f, and do substitutions to get all the primes out. So just try it. that part, making sure you know to use the chain rule. Okay? All right, that's it then? Those were the only questions? And I can trust you guys that you're really doing your homework. I don't have to collect these from you and then get angry. Because I will. And then I'll get extra angry if they're not really done. Show work. Do not just circle things, please. There should be actual work, evidence that you're doing the problems. Okay? Even if an answer's not circled, there should be evidence that you tried the problem. All right. Otherwise, let's do review 4. So I'm going to give you notes on review 4 and review 5. If there's time, I'll let you try a few example problems that I picked out. If there isn't time, then those will end up being homework. So going all the way back to the beginning, when derivatives were pretty easy. One of the first applications you ever learned was how to make the equation of a tangent line. A tangent line needs 2 things. What are the 2 things you need? M, which is a slope, and I heard the other one, a point. Why do we need those? Because that's the equation of a line we used. If you are in calculus, you always use this equation of the line. Please don't use y equals mx plus b to write your equations. Most of you will do it incorrectly. Leave it in this form. You don't even have to solve for y. The other way that you may see the equation, instead of writing it this way, you may see it as y minus f of a is equal to f prime of a times x minus a. But they all match up. This y, that just means y. Slope, that just means slope. X, that's the x value. Those are the 2 ways that you might see the equations written. So that's where we're going to start. If you write the equation of a tangent line, you need a slope and you need a point. Please make sure that this is a value. Please don't put the derivative function in there. It actually makes your equations very complicated, and then you try to simplify and it doesn't work out. You find your derivative at the number first, at the value of a, turn that into a value, and put the value of the slope in here. That should be a number. Should not be an equation. Horizontal tangents all have the same type of slope. What kind of slope? 0, so f prime of a would be 0. All vertical tangents have the same kind of slope. They are all undefined. Because vertical lines, you knew that from Algebra 1, vertical line slope is undefined. So that's pretty much the basics, very much basics. Horizontal tangents, if I ask you to write the equation of a line, a horizontal line, let's say, at the point 2, 4, how do you write any equation of a horizontal line? Y equals. So once I know the point, the equation of the horizontal line would be y equal to 4. What would be the equation of the vertical line? X equals 2. So remembering, we don't use this complicated equation, the point slope form, if you're just doing horizontal and vertical lines. They're special because they're easy. Okay? Alright, so tangent line's done. Moving through to do normal line. Normal line, please, please, please remember to use point slope. So stay away from y equals mx plus b. Y minus y1 equals m times x minus x1. What's the difference between a tangent and a normal? These will stay the same. Your point's still the same. Your slope, your normal slope is opposite, reciprocal of tangent. Of the tangent slope. In the other class, I did go through why. Why can't you just take y equals mx plus b and change this to an opposite reciprocal? That looks like the same thing we're doing here. We're keeping everything else the same. We're changing just the slope between a normal and a tangent. This equation, just to graphically show you, says that if I pick my point, x equal to 2, and then do the slope, pretending, if I want to make the equation of the tangent line, it says use the same point, but do an opposite reciprocal slope. So that makes sense, right? Okay. This line would go up and touch here. This would be the y-intercept. If all I do is change the slope in the slope-intercept form, I don't find the equation of the normal line at x equal to 2. I end up finding the equation of the normal line at the y-intercept. That's why it doesn't work, but I still have a good amount of you that keep trying to use it. It won't find you what you wanted, it finds it at the y-intercept. That's why we don't use the y-intercept form. Okay, it's not as helpful. So stay away from this guy, please. Okay? Opposite reciprocal. If my slope is -5, then my perpendicular slope is positive 1/5. That's why I call it an opposite reciprocal, not a negative reciprocal, because I don't want you to think it has to be negative. Opposite sign, flip your fraction. All right, over, under. So, over, under approximations, we deal with concavity, which is the second derivative. Over, under approximations, you'll see this come back when we do rams. Those are the two times we talk about approximations. Tangent line approximations, and then rams. Okay? So this guy deals with concavity. So you should be able to draw a concave up graph, and you should be able to draw a concave down graph, and then just draw one tangent line. Doesn't matter where. It could be decreasing, could be increasing, doesn't matter where. But if you look at the tangent line is always under f of x, under the real values. Whereas over here, if I'm increasing or I'm decreasing or my slope is 0, doesn't matter, all of them, my tangent line is over f of x. Okay, so we do have to be able to write and figure out if the tangent line is going to be over or under. And then linear approximation, which I think I want to put on the next page. Linear approximation, what did I tell you? That's the exact same thing as a tangent line. So it has a different name, but we build it the same way. I'll go through what it looks like, though, because it may look a little different, because if they ask you to write the equation and then it's a multiple choice, it may look weird to you. So, start with what we know is a tangent line. That's the original one. You don't have to write these two. This is the other one that's exactly the same thing. And then the linear approximation, all it does, it says, instead of writing y, and y is a number, I'm going to write where I'm taking my linear approximation. That's the difference. And instead of subtracting the y value, I'm going to add it to the other side of the equation. So I just moved it, and I copy everything else. So you'll see this be the format for a linear approximation versus a tangent line. We tend to use these formats up here. Only difference. So if I ask you to write I give you the point 2, 5, I tell you that f prime of 2 is -3. The linear approximation then looks like this. You get to write the point. I wanted it at 2, 5. That just tells us where my approximation was made, equals the y value of the point, 5, the derivative of the point, -3, x minus the a, that's 2. Then they're going to ask you, do the approximation, approximate at x equal to 2.001. So where does 2.001 go? In the x, so common sense, right? As long as you understand your function notation, you should be fine. All right? Good? Tangent lines? All right. That should be everything for this packet. I'm going to move into particle motion. Actually, let me get you to do a problem. Let's do this one. So I gave you the rule without chain rule, actually partially to answer Baldrick's question, which was what do you multiply by. If I give it to you without the chain rule, then it becomes obvious what you multiply by. The derivative of the outside, so y prime would be, this is your inside, so the derivative of the outside just looks like this. It's a pretty big derivative of the outside. I get that it looks a little weird, but then leave the inside alone. Then multiply by. Third step, derivative of that inside, which is what Ty was telling you, du dx. And then you just have to be able to simplify it properly. So, in this case, I picked this question because it's not asking you for the derivative. It means you don't have to simplify it at all. Because what I'm going to need this. So I don't even simplify it. I just go through and I write in my 0. And I get, I believe, 1/2. Right? So then I can write my equation of a tangent line, which still, y minus 0 is equal to 1/2 times x minus 0. Doesn't show up, does it? So you do have to be able to change it. Did I make any mistakes? Hopefully not. Okay, so then, now what do I do? All my x's need to go to that side, so that would be negative 1/2 x plus y equals 0. I still don't see that. Multiply by, not just 2, negative 2. Multiply everything by negative 2 so I can change the form. So negative 2, that'd be x minus 2y equals 0. So the form that they gave might not be what you're used to. The other option, change all of these into y equals. The other option is you could physically change all your equations into y equals mx plus b form so that they look more noticeable, or you got to change yours into one that matches their form. Okay? Matthew? I move that to the other side. And then I notice that none of them have fractions, and none of the x's are negative. So I multiply the whole entire equation, both sides of the equation, by negative 2. Negative to get rid of the negative, 2 to get rid of the 1/2. Good? All right. Okay. Let's do particle motion then. I think I had a few more in there, but oh well. All right. So get review 5 out. Same thing. Some of this is going to be extremely repetitive, and if you feel like you know it's in your foldable, you don't have to write everything down, okay? You should write down the stuff that you're staring at and you're like, oh my god, I don't remember that at all, okay? Or you can print and then copy it later. You want to do the listening. All right, particle motion. So major things about particle motion, just remembering that the position function is what I consider the, quote, starting function. We use s of t for that. Sometimes you'll see x of t, or you'll see y of t. Okay, displacement is just a definition. Displacement is physically from where you ended time being b, so time equal, let's say in the first 10 seconds, b would be 10, minus s of a, which would be the beginning position. So that would be the definition of displacement without an integral. This packet, if I didn't make any mistakes, you shouldn't need integrals, because we haven't reintroduced integrals yet. I make mistakes, though. Sometimes you might. All right, velocity is the derivative of position. Acceleration is the derivative of velocity, but it's also the second derivative of position. Okay? Other way that you could write that, just so you see that other notation. Sometimes we forget that we can write our functions that way. So, basic stuff, you know all this, right? That's the easy stuff. Moving forward, velocity, moving forward or up, moving backwards or down, resting or stop, and then changing directions. Those are all the things we can identify with velocity. Okay. Nick, forward, what does that mean, forward or up? Is positive. Good. Gustavo, how about back or down? t is negative. Lottie stopped. V of t equals 0. And this is where we were not allowed to say it is positive, it is negative. You have to say velocity is positive, velocity is negative. You have to say what it is because we talk about so many functions. Ruth, changing direction, definition. Change of sign and 0. Yeah, we want to use both. So velocity is 0 and I'm going to even write it v of t changes sign. And anytime you want to talk about these questions, what's the easiest thing to make? Sign chart. You guys are supposed to rock at particle motion questions. You should not be getting those wrong. When you see one, you should be getting a 9 out of 9. Okay? That's stuff we've just been doing over and over and over. Alright, speed. Speed is the absolute value of velocity. Okay? Speed, we're going to do graphically, analytically, which means by hand or by algebra. Okay, so if I want to just identify speed on a graph, it would just be the absolute value of velocity. What do the absolute value bars mean graphically? It's always positive. So if I wanted to take a graph of velocity and make the speed graph, Yosef, how would I make the speed graph? Good. So take your negative velocity and reflect across x-axis. So if I just want to identify the speed graph, that's all I would have to do. You guys know how to do absolute value, so you're just using that skill. Analytically, if I ask you to find the speed, you're physically going to take the velocity and make it positive. Which is just the definition, again, of absolute value. The harder questions you guys are asked is speed up versus slow down. Write your definitions in. So graphically, how would you do it? Analytically, how would you do it? So that is something you are writing in on your own at your tables. If you need help from your table members, you can get help from them, but don't sit there staring at me, please. Speeding up, Ty, graphically. How do I know if it's speeding up? What's it? What's it? Of what function? You sure? I can't use the position function? So, okay. So I want to use the position function, and how do I look at it then? Definition is? So if the position function goes away from the x-axis, it is? Lies! James says lies. Why? Velocity graph is the only graph that you can use to analyze speed, unless you want to create the velocity graph from position. I probably would not want to do that. Most probably you'll be given the velocity, but you have to know that that's what you need. So the velocity graph goes towards or away? Oh, I don't trust you anymore. You just tell lies. James speaks truth. When your velocity graph goes away from the x-axis, you are speeding up. The negatives are the ones that people get confused about. But if I'm at a velocity of -3, then how much is my speed? And then I move to a velocity of -6. Now my speed is 6. So it did get bigger, even though I'm making it more negative, which is actually a smaller value. So this is the way to kind of avoid that. And then v of t graph goes towards. how many times you had this written in your notes, in your foldable, like all over packets. It's everywhere, and yet people still get it wrong. You have to name the function. You can't say it, as I just said a minute ago. We don't use the word it. You got to identify. All right, analytically. So, analytically, Jamie, how do I know that I'm speeding up? Good. And then obviously then are different signs. So literally, you're going to give me a heart attack if I have to grade one more paper that says the particle is slowing down because acceleration is negative. You know what you just told me? You told me that acceleration was negative. That's all you've told me. You've also said that velocity is decreasing. That's also a true statement. But you have not told me that or shown that the speed is decreasing, which is what slowing down means. You need two functions for speed, always. Velocity and acceleration. This is a trick. This trick actually is using the exact analytical definition. Guarantee you that it is. If you draw the graph, and anywhere that you think the speed is going up, I bet you can find the velocity and the acceleration at that point, and it will be the same sign. So it's using the same concept. Last thing, let's do, this one is a weird one. It's probably not in your packet, but towards or away from the origin. Talked about it maybe once. I used to put it on test without teaching it because I think it's something that you should be able to understand on your own. It's a particle motion problem, so these are the functions that you would be thinking about. Here's the origin. Does it matter which way I stand? Will it change which way I am moving? So I put a little man on my left side. I move towards the right. So if I'm standing over here, my position is negative. If I'm over here and I'm going this direction, my velocity is positive, because origin, this way would be to the right. Over here, my position is positive. But if I do positive velocity, I'm not moving towards the origin anymore because I passed through the origin and now I'm on this side, so that should make sense. What are the two functions that we're discussing? Position and velocity. Where you stand, where you are, and what direction you're moving will tell you if you're going towards the origin or away. So I don't know the rules. I don't have them memorized. But if you draw this picture, it pretty much will tell you. So let's say your position is negative. And your velocity is negative. Am I moving towards the origin or away from the origin? Away. And then over here, I'm also moving away. These are my two aways. And here are my two towards. And if you want to go through all of your rules, you're more than welcome to. If you go towards versus away, what do you notice? For towards, that would be this guy here and this guy here. So my position was negative, and my velocity was positive. That's one way. Or my position is positive, velocity is negative. What do you notice about your signs? So what do you think is going to happen here? Towards, that was away, so I think it's a waste to memorize it. I really do. That's why I don't teach it. That's why I don't make you memorize it. That's why you haven't written this table 30 million times, because you may or may not get the question. You will get a question about speed. You will. There will be a speed question somewhere. but this one you may or may not. So what do I ask that you know? Anytime they're talking about motion, it's a particle motion. If we're talking about particle motion, you have three functions you can analyze. And how fast we're moving, like if we accelerate or decelerate, that doesn't change which way we're moving. It just makes you move faster or slower in that sense. These are the ones that'll tell you which way you move towards the origin or away from. It helps to just draw the picture. I just draw a picture every time. I don't have the rules memorized. I also don't like memorizing these because they seem similar to what? Where have you seen the opposite sign versus same sign? Speed. You've seen it with speed, and I don't want you to confuse this with speed. So I don't memorize it. I deal with this guy. That's pretty much everything. Is there anything you can think of from particle motion that you might have a question about? This is before integrals, hopefully, if I did the packet correctly. Okay?